Alright, now that we have the gear relationship, the gear pair relationship specified, we can now put they call it a servo motor, onto one of the axes to allow the two to spin with a certain rate of revolution. So we'll come up over here into the menu and we're going to select on the servo motor icon. And again, the only thing we need to define here in terms of its location is which one we want to rotate. So we'll rotate the larger gear, because one revolution of the large gear is going to cause 3 revolutions of the small gear, being the 24 tooth to 8 tooth ratio. So we'll select the motion axis of that gear, and it does a lot of extra stuff showing you what it's related to. And we could flip the direction to change the direction of rotation, but we'll accept the default for right now. And then we go from the type tab to the profile tab, and the motion we want to specify is a velocity, the velocity in degrees per second. And let's say we'd like to do a constant value of 90 degrees per second, so it'll take 4 seconds for a complete revolution, and we can say OK. And now you have this little red icon that shows sort of like a corkscrew, defining that there's a servo motor as part of it. So now that we have the servo motor specified, we can come over here to mechanism analysis, and what we want to do is the servo motor is selected under the motors. The type of analysis that we're going to do is position, as opposed to kinematics and dynamics, which we can get to at a later point in time. And the start time is going to be at t equals 0. The end time for the motion will be at time t equals 4, because 4 seconds times 90 degrees per second gives me a full rotation of 360 degrees. And let's say the frame rate, let's do, how about 50 frames for every second of rotation, because that'll be fast enough for what we want to do. Let's make it 100 frames. We'll do it nicely. So now, and it's going to tell you the name that you're going to change it under, analysis definition 1. Of course, we could always change it to first gear test. And what we're going to do is just say run, and the gears will rotate themselves. And if you were looking very carefully, you'd see that the large gear is going to rotate just once, and you can say OK. And now once you have them created, you can come under the play buttons, and it's called playback. Here's your first gear test, and you select on the play button again. It brings up your standard animation controls, and the loop situation is selected, and you can define the speed that you want the animation to run at, and click run. And it's not running in real time. You can see what it's running over here. So obviously this is running slower than 90 degrees per second. It's going to take 4 seconds to fully run through, and now it'll just keep on playing. You could go under capture and make an MPEG movie if you're so inclined. You would just have to give it the name, browse to the location, decide how you want to do it. MPEG is obviously what we want, as opposed to making JPEGs, and you can select a different frame rate per second. I'm going to cancel out of that, and I'm just going to let this play. And you can, and I should have just left it playing. My apologies. I'm going to leave it playing here and speed it up, and we can rotate it in real time as we're watching it. So we can actually select the back so we can actually see what's going on here, and we could actually look at it in a different wireframe mode, so we can get in here nice and close, and we can see that our gears are meshing kind of nicely. Alright, so that finishes our first real mechanism, creating a full assembly with motion and some nice action. Of course, now you could go through and create a compound gear train or anything else that you'd like to work with right now.